As an example, consider this Writers1 class. The class creates a private array containing writer instances. So this works with the writer class. And it lets you add writers to the array by calling the class's add method, which handles resizing the array as necessary. Okay, so we have a private field. Current size is 4. Set it equal to 4 initially. Keep track of the number of writers. We have a field for that. The current number of writers that are in the array. The array itself. The constructor, which instantiates a new array of writer objects. And then here's the add method that lets you add a new writer. So first check to see if the writer count is greater than the length of the writers array. So again, the writers array is this private array right here. So if the count is bigger, then we're going to double the current size of the array. Now, this for smaller numbers of objects works fine. We're never going to have more than a handful of writers within this array, but this can cause problem with larger numbers. So just be careful of that. But the idea here is that you don't want to resize the array too often. And then when you resize it, you have to actually reset the size of the array. So you have to go through this code of cloning the array into a temporary array, creating a new array of the current size, and then copying over the elements from the temporary array into the new array, and then getting rid of the temporary element. Okay, and then once that's done, or if there's enough room still within the array to add a new member, then it goes ahead and adds the new writer to the element of the array, and it uses that writer count variable that I defined up there, and then once it assigns the value of the array, it increments that variable. Okay, so this code right here incorporates a lot of different techniques that we've used in the C# courses so far. All right, and then it also exposes the length as a public method, as a read-only method. Okay, so to recap, the class contains a variable that maintains the current size of the array, a variable that maintains the number of writers in the array, and the array itself. And then the constructor and the add method and the length property help you manage and get access to that information. Okay, one of the things that's important about how this class is defined is that external code cannot get direct access to this writers array. So you can add items to the array from the external code, but that's all you can do for now. So let's take a look at code that exercises that. Test Writers1. Okay, so this is using the Writers1 class, the class I just showed you, and that's the writers array, adds different people in the states. And then, because the array is initially sized at 4, this doesn't cause a resize, but this does. And once that statement executes, there's actually 8 available elements because we doubled the size. Each time we resize the array, we double the available array elements. Okay, now how can you retrieve an item by number? Well, I can try doing something like this, but as you can see, I get a red squiggly. Hover over it, says cannot apply indexing with square brackets to an expression of type Writers1. And that kind of makes sense because the class itself isn't an array. It has an array within it, but I can't directly access the elements of that array using this kind of syntax. And then what if you want to retrieve a writer by name? This isn't going to compile either, because it just doesn't expose that kind of functionality. Okay, so we have the start of a class that does what we want. It stores, it's essentially a collection object for writers. And so The way you add these behaviors to let it behave more like an array is by adding two indexers to the class. And I do that in this writers2 class. Okay, same sort of stuff, current size, writer count, the array itself. The constructor that allows you to construct a new array and initializes that array. The add method does all the same basic stuff, the length method. But then here is the new stuff. There are these two new methods that are actually indexers. And what's interesting about these methods is that they're both named this. This is a special name that indicates to the C# compiler that it should use the procedure when you ask the class to retrieve an item using an index value that matches the procedure's parameter type. So with this indexer, I'm going to be able to retrieve elements by index. And with this one, I'm going to be able to retrieve them using the writer name because I'm passing in a string. Okay, so that's the overall declaration of it. Notice that it's going to retrieve an object of writer in both cases, which makes sense because if we have an array, an internal array, we want to get a writer object, we're going to return that writer object. Okay, another strange thing about the syntax is that the parameter that it's passing in is delimited by square brackets, not by the usual round brackets of a regular method. Okay, so that's another difference in that syntax. And then each indexer provides getter and setter methods, much like a property. In reality, the indexer is supplying an indexed property, retrieving data from the internal array as if it were a property of the class indicated by a numeric or string index. Okay, so each of the getter methods finds the element corresponding to the index that you supplied and returns that element. So in the case of the numeric index, it checks to see if index is less than 0 or if it's out of range. If it's higher than the size of the array, then it throws this index out of range exception. Otherwise then it returns whatever writer is at that index value. And what's interesting about the way that we wrote this code is that the element that it returns may not be have a writer element there yet, because the number of available items is larger potentially than the number of writers that we actually have stored in the array. Okay, and then the getter for the writer name uses a for each loop in order to find the writer with that name and then returns that item. If it doesn't find something, then it throws this index out of range exception and says unknown writer name. All right, and then each of the setter methods attempts to set the value of the requested item. If the procedure can find the item, it sets its value. If not, it raises that same exception, index out of range. Okay, so it provides a way to update the value of any of the elements. Okay, so I know this is a little bit confusing code. There's a lot going on here. But if you take the sample code and play with it and step through it and see what is actually happening, it really is a pretty slick way of providing this kind of functionality. Okay, so here's another instance of a test method, testWriter2, creating this new writers2 object that contains an array of writers, using the add method to add all of the writers. And then, now I can write code like this. I can access writers, Doug, pass in that, and access the home state. Notice I don't have any red squigglies, and so this code compiles just fine. And then I can look for a writer, Andy, and update that Andy is apparently moved to New York. So it's going to replace, if it finds this element, it's going to replace the Andy object, which is not in the list, and update it with that information. And let's see. Yeah, the code isn't quite that robust, so I'm going to change this. And let's say that I instead move to Georgia. Okay. And then it goes through and loops through and displays all of the riders. And then I'm also going to do something that triggers an exception by trying to access an element that's out of bounds. Okay, before I talk about the rest of the code, I'll go ahead and test this. Have Q. Okay, and so you can see it accessed that element, piece of information, the hometown or home state, and then listed all of the riders, and then got the exception thrown, and it was said index was outside the bounds of the array when I tried to access something that was outside the bounds of the current array. Okay, so we've got a much more robust class now that supports some of the typical ways of using arrays. But it still doesn't fully work. So if I uncomment this code, what this is doing is it's attempting to loop through, using a for each loop, each of the riders within that riders collection. And as you can see, it says for each statement cannot operate on variable of type arrays.riders2 because arrays.rider2 does not contain a public definition for get enumerator. Okay, so the big gap still remaining is that we can't iterate through elements of the class using a standard for each loop. Now the reason we can't is that because in order to support enumeration, which is necessary for a for each loop like this, the class has to implement the system.collections.IEnumerable interface. And that requires the class to include a getEnumerator method, that's the method that was mentioned in the syntax error, that returns an IEnumerator object. Okay, so I can go over here and I have a getWriters3 class. It implements that IEnumerable interface. And what that requires is way down here that it returns an object of type IEnumerator. And this is the first insight into using interfaces where you can actually return, you specify that you return an object of a type that implements an interface. It doesn't have to be type of an object, doesn't have to inherit from certain things, but it returns an object that implements IEnumerator in this case. Okay, and so this is implement as part of implementing that interface. I have to provide a getEnumerator method. Okay, so let's step back a second and think about what happens when you execute a for each loop. The .NET runtime asks the class for its first element. So if I come back over here, this code, it's going to ask for the first element and put a reference to it in that item variable. And then it asks for each succeeding element as the loop progresses. When there's no more elements to return, then the class has to indicate that to the .NET runtime as well, that there's no more elements and it's time to drop out of the loop and do whatever's next after the loop. Now, you could write all of the code to do that yourself, and as of .NET Framework 1.0, that's the only choice you had. But starting way back in .NET Framework 2.0, you can use the yield statement to simplify all this. All you need to do is supply the appropriate for each loop within the getEnumerator method, and the C# compiler does the rest of the work for you. Okay, so this class implements all of the same code as Riders2. It's pretty much identical, except for the name. But then implements the interface and implements this. And so what it's going to do is it's going to loop through each of the items in Riders. And keep in mind that I'm in the class that contains that Riders element right there. So the code has access to the array, the full features of that array, so I can do whatever I want with the array. And then it uses that yield keyword to return the item as it's requested. I'm not sure yield is probably the best name for that, but essentially what it does is each time that the calling code requests an object, it returns the next object in that array. Okay, and then I have a method to exercise that. Oh, let me comment that code back out. There we go. All right, so here's test writers 3. I once again populate it with writer objects, and then I'm going to loop through using a for each loop, and it's going to write out each of the items. So when I run this code, I'll select R, and there, now it's able to successfully loop through that collection of arrays embedded within that writer's object.